It is the biggest sales day of the year. Thousands of customers are clicking buy every second. Then suddenly, a server in your Kafka cluster dies. Broker 2 is gone. And Broker 2 was hosting partition 1 of the orders topic, the exact partition containing order 42. So the question is immediate and brutal. Did you just lose customer orders? If Kafka stored only one copy of each partition, the answer would be yes. The machine died, the data died with it, and your support team is about to have a very bad night. Kafka avoids that by never trusting a single machine. Every partition is copied across multiple brokers. The number of copies is called the replication factor. If the replication factor is 3, then partition 1 exists on 3 brokers at the same time. 3 brokers labeled Broker 1, Broker 2, and Broker 3, each containing an identical partition 1 log with order 42 visible in all 3 copies. So even though Broker 2 crashed, order 42 still exists on Broker 1 and Broker 3. But this creates another problem. If producers could write to any copy independently, the replicas would drift apart. One broker might receive events in a different order. Another might miss writes entirely. Eventually, the copies would disagree about reality. Kafka solves this with a leader and follower model. For every partition, one replica is elected leader. The other replicas become followers. Producers send writes only to the leader. Followers continuously pull data from the leader and copy it in the exact same order. That single leader is what gives Kafka a consistent event history per partition. Broker 2 marked as leader, receiving producer writes, while Broker 1 and Broker 3 are followers, pulling replicated events with green check marks showing synchronization. Now we can introduce an important term, in-sync replicas, shortened to ISR. A follower is considered in sync if it is fully caught up with the leader. Kafka tracks this carefully because not every replica is safe to fail over to. If a follower is lagging behind, promoting it could lose recent events. So ISR really means trusted replicas that are caught up enough to safely take over. Now, back to the disaster. Broker 2 explodes. It was the leader for partition 1. Here is what Kafka does next, and it usually happens within seconds. First, Kafka detects the leader is gone. Then it checks which replicas are still in the ISR set. Suppose Broker 3 is fully caught up. Kafka promotes Broker 3 to become the new leader. Producers and consumers automatically reconnect to the new leader and continue processing. Broker 2 crossed out with a red X, Broker 3 promoted with a crown labeled New Leader, and producer and consumer arrows redirected to Broker 3. And this is the key point. Order 42 never disappeared. It was already replicated to Broker 1 and Broker 3 before the failure happened. When Broker 2 eventually comes back online, it does not immediately reclaim leadership. It rejoins as a follower and copies whatever data it missed until it catches up again. Now, here is the subtle but extremely important detail. Replication alone does not guarantee zero data loss. The producer acknowledgement setting, called acks, determines when Kafka considers a write successful. With acks set to 0, the producer sends the message and never waits for confirmation. Fastest possible throughput, but messages can vanish during failures. With acks set to 1, the producer waits for only the leader to confirm the write. Better, but still risky. If the leader crashes before followers replicate the event, the latest messages can disappear. With acks set to all, the producer waits until the in-sync replicas confirm the write too. That means the data exists on multiple trusted brokers before success is returned. In production, a common safe setup is replication factor 3, acks equals all, and min in-sync replicas set to 2. That combination prevents Kafka from pretending a write is safe when only one broker is alive. So the mental model is simple. Partitions are replicated across brokers, one replica leads, followers stay synchronized, In-sync replicas are trusted for failover. If the leader dies, another in-sync replica takes over automatically. A server burst into flames during your biggest sales event, and your orders survived. That is what Kafka Replication buys you.